What if everything we thought we knew about celestial mechanics is about to change? The 3IATLAS comet continues its baffling journey, defying conventional understanding with its anomalous trajectory. This isn't just another rock hurtling through space. This is a cosmic detective story, and we've just been handed some incredible new clues. Join us as we dive into the very latest updates, exploring the intriguing new data that could redefine our place in the cosmos. So, what exactly is 3IATLAS? Let's do a quick recap. Discovered by the Atlas Survey System, its full name is 3I 2017 U1. That I is crucial. It stands for Interstellar, meaning this object originated from outside our solar system. It's only the third such object we've ever confirmed, following in the footsteps of the famous Oumuamua and Borisov. But from the moment we started tracking it, 3IATLAS has been a puzzle. Unlike typical comets whose paths are dictated purely by the sun's gravity, this visitor exhibits what scientists call non-gravitational acceleration. It's pushing itself, ever so slightly, off its predicted course. This strange behavior immediately sparked a massive debate. Is it outgassing, where sunlight heats frozen gases, causing them to shoot out like tiny rocket thrusters? Or is something else, something far more exotic, at play? This is the mystery we're unpacking today. Now let's get to the heart of it. The brand new trajectory updates. For months, observatories around the world have been glued to their telescopes, meticulously plotting every tiny deviation in the path of 3IATLAS. What they've found is nothing short of remarkable. The latest data, compiled from dozens of sources, shows that the comet's acceleration isn't constant. It fluctuates. There are periods where it pushes harder, and periods where it seems to coast. This isn't what we'd expect from simple, uniform outgassing from a spinning, icy body. That process should be relatively predictable. Instead, the trajectory data paints a picture of a far more complex and dynamic process. It's like watching a ship adjust its sails to catch an unseen wind. This variability has sent shockwaves through the astronomical community, forcing everyone back to the drawing board. So, what could be causing these strange fluctuations? This is where the theories start to get really exciting. The leading hypothesis is still related to outgassing, but with a twist. One idea is that 3IATLAS isn't a uniform snowball. Instead, its surface might be a patchwork of different materials. Some areas could be rich in highly volatile ices like nitrogen or carbon monoxide, which would sublimate, turn directly from solid to gas, with even the faintest warmth from the distant sun. Other areas might be bare rock. As the comet tumbles through space, different patches face the sun, causing jets of gas to fire off at irregular intervals, creating the push and pull effect we observe. It's like a sputtering engine instead of a smooth one. This theory suggests a complex, varied surface, hinting at a formation history unlike anything we've seen in our own solar system. But what if it's not just sputtering jets? Let's explore a more radical idea. Some scientists are revisiting the nitrogen iceberg theory, famously proposed for Oumuamua. Could 3IATLAS be a fragment of a Pluto-like planet from another star system, a chunk of frozen nitrogen ice? If so, its unusual shape and composition could lead to the kind of uneven outgassing we're seeing. As it gets warmer, different layers or facets of the iceberg could sublimate at different rates, producing a chaotic pattern of acceleration. Imagine an iceberg carving here on Earth, but on a cosmic scale, driven by starlight. This would make 3IATLAS a messenger from a planetary system vastly different from our own, carrying clues about its alien origin. The data is still inconclusive, but the nitrogen iceberg model fits some of the observed variations surprisingly well. Of course, whenever we encounter a mystery in space, the conversation eventually turns to more speculative possibilities. While the scientific community rightly focuses on natural explanations, the anomalous nature of 3IATLAS has reignited discussions about technosignatures, evidence of extraterrestrial technology. Could the non-gravitational acceleration be controlled? Is it possible that what we're seeing isn't a natural comet at all, but an artifact? Perhaps a solar sail, using the pressure of sunlight to navigate, or some other form of propulsion? Now, let me be very clear. This is pure speculation. There is absolutely zero direct evidence to support this. However, the goal of science is to follow the evidence wherever it leads, and when an object defies our models so persistently, it's the job of scientists to consider all possibilities, no matter how unlikely, and then try to rule them out. For now, every natural explanation remains on the table and is far more probable. Let's ground ourselves back in the data. What's next for 3IATLAS and the scientists studying it? The object is now heading away from us, getting fainter with each passing day. Our window of observation is closing. The race is on to gather as much data as possible before it disappears back into the interstellar void forever. The James Webb Space Telescope might try to get one last detailed look, analyzing its chemical composition for definitive clues. Radio telescopes will be listening for any unusual signals, just in case. The data we already have will be analyzed and modeled for years to come. Every piece of information, from its brightness variations to its subtle wobbles, will be scrutinized. 3IATLAS is like a cosmic message in a bottle. We might not be able to fully decipher its message before it's gone, but the clues it leaves behind will shape our understanding of the universe for a generation. The discovery of interstellar objects like 3IATLAS is transforming astronomy. For centuries, we could only study our own solar system. We were like islanders who had never seen a ship from another land. Now we know that the cosmic ocean is full of visitors. Each one, Oumuamua with its bizarre shape, Borisov looking like one of our own comets, and now 3IATLAS with its sputtering journey, gives us a unique snapshot of the galaxy's diversity. They tell us about the building blocks of planets around other stars and the violent processes that can fling them out into the void. Projects like the upcoming Vera C. Rubin Observatory are being designed to find thousands of these objects. We are standing on the shore of a new era of exploration, one where the galaxy is, quite literally, coming to us. The story of 3IATLAS isn't just about one strange comet. It's about our first steps into a much larger cosmic neighborhood. What have we learned today? We've seen that the mystery of 3IATLAS has only deepened with the latest trajectory updates. Its fluctuating, non-gravitational acceleration challenges our simple models of cometary outgassing. It forces us to consider more complex scenarios, from a patchwork surface of volatile ices to the exotic possibility of it being a nitrogen iceberg from an alien solar system. This single, distant object is pushing the boundaries of our knowledge and fueling one of the most exciting scientific detective stories of our time. While we may never know its true nature for certain, the pursuit of that answer is what science is all about. It is a testament to human curiosity that we can look up at a faint speck of light millions of miles away and ask such profound questions about our place in the universe. Thank you so much for joining us on this deep dive into the cosmos. The universe is full of wonders, and we're only just beginning to scratch the surface. If you found this journey as fascinating as I did, please hit that like button and consider subscribing for more explorations into the mysteries of space. Let us know your theories about 3IATLAS in the comments below. Stay curious and keep looking up.